this is one of my linear algebra videos where I'll explain you how to find the dimension and basis of column space, row space, and null spaces of matrix. I believe you know what is column space or row space or null space, because this video is mostly focused on how to find them directly from a given example, instead of explaining you the theorems or the like proofs. If you are looking for the proofs and theorems, it is better if you can visit other videos and other website for them. That would be actually better. And to reduce the time, I'm not going more into detail of the theorems and the proofs. Rather, I'll just find the I'll just give you an example and I'll show you how to find them directly from them easily. But just to give you a quick idea, column space, row space are basically the span of the columns and the rows. And here I'll show you how to use them to find the dimension and basis of the matrix. For example, let's take a matrix. Suppose the matrix A is 0, 0, 2, minus 2, 0, and 6. This is a minus. And 0, 0, 0, minus 2, 2, 6 again, 0, 0, minus 4, 5, minus 1, minus 15, and 1, 4, 2, 2, minus 7, minus 8. Suppose this is given to you, right? Now, if you do the reduced row echelon, how to find the reduced row echelon form, that is a separate video. You can check out that, or you can use some online calculator to find out the reduced row echelon form. That will also be helpful for you. But you need to know actually how to find the reduced row echelon form of the matrix. And if they directly give you that, that is actually already the math has been like easier for you, because if this is directly given to you, you can work directly from this reduced row echelon form of the matrix instead of this. It's actually the reduced steps of this. Now, if we do that, you'll find that the reduced row echelon form of matrix A is 1, 4, 0, 0, minus 3, minus 2, and you have 0, 0, 1, 0, minus 1, 0, 0, 0, 0, 1, minus 1, minus 3, and 0, 0, 0, 0, 0, 0. So if you do the reduced row echelon form of this matrix A, you will see it is actually giving you this one. Now, this is what you need to find the dimension and basis of the column space and other null space and the row spaces. So let's first find the column space and the basis of the column space. So the column space of a matrix are basically the rows, the columns, which has a 1 and all the zeros down. Okay, so you have 1 here. Let's take a pencil. So you have 1 here, you have 1 there, and you have 1 here. And that one has all the zeros down. See? So these are the column space of your matrix. So you have the column which is column 1, 3, and 4, right? So these are your column spaces, column 1, column 3, column 4. These are your column spaces. The basis of column space So you know that your column space is 1, 3, and 4. So go back to the original matrix, the main matrix you have, right? So you have C1, which is column 1, column 2, and column 4, means column 3. So these are the columns, those are the bases of this column space. So your basis is 0, 0, 0, 1, and 2, 0, minus 4, and 2, and minus 2, minus 2, 5, and 2. So these three columns are your column bases of the column space of the matrix A. Okay, so this is how you find the column space from a given matrix. Now let's go to the row space. Again, you can work to find the row space on row reduced row echelon form of matrix A. So here you see all the columns that is like that has 1 in the front. For example, like you have 1 here. So this one, this row has a 1 in the beginning. This row has a 1 in the beginning, that row has a 1 in the beginning, right? And there are no other numbers before it, and this column has all 0. So your row column space are basically the rows, the row space, the row spaces are the rows which is starting from 1, and there are no other numbers before that. So here your row spaces are row 1, row 2, and row 3. R4, row 4 is not, because it contains all 0 matrix. So you cannot count as a row space. Now the basis of the row space, similarly, you take these rows and go back to the original matrix, right? So you just take that. So your first row is this. So that gives you this one, which is 0, 0, 2, minus 2, sorry, 0, 6. That is your vector 1. And your vector 2 is the second matrix, which is 0, 0, 0, minus 2, 2, and 6. And your third matrix is this one, which is 0, 0, minus 4, 5, minus 1, and minus 15. So these are the three vectors which are the basis of the row space that you get from the row echelon form, reduced row echelon form of matrix starting 1 in the beginning of the rows, and the basis of this row space are the rows of the matrix A. That's how you find the column space and row space of the matrix. Now I'll show you, so the dimensions. The dimensions of the column space is 3 here, because you have 3 columns, right? Similarly, the dimension of the row space is also 3, because you have 3 rows here, right? Now we need to go to the null space, which is little different than this. So to find the null space, you need null space. So to find the null space, you need the reduced row echelon form again. So here we have the reduced row echelon form, which is this. Let me write it for your better understanding. So we have the reduced row echelon form of A, which is 1, 4, 0, 0, minus 3, minus 2, and you have 0, 0, 1, 0, minus 1, and 0. We have 0, 0, 0, 1, minus 1, minus 3, and we have all zeros at the fourth row as the fourth row. This was our reduced row echelon form. So we need to find the null space from here. How to find that? The way I find it is this. For example, like you have the rows here, or the columns. So there are 4 rows and the 1, 2, 3, 4, 5, 6 columns. So you have x1, x2, x3, x4, x5, and x6, and you have x1, x2, x3, x4 as the rows. Now we can write down, we have to do this, we have to solve the system of equation here. To get the basis of the null space. So how to get the how to solve the system of equation? The way I do, for example, like you have the 6 columns here, right? So we have x1, x2, x3, x4, x5, and x6. There are 6 columns we have. Now, if we take the rule of finding any x is, if any particular x is 0, you take 1 for that. Otherwise, you just solve for the way you solve for general equation. For example, like if you have that equals to 0, how do you find the x's, right? Now, you have the x1, which is a 1. If I just take this as x1, I'm getting this 4. If you take this on the other side of the equation, you're getting minus 4. So that gives you minus 4x2, right? And this x5 is coming on this side. So you have 3x5, right? And this is x2, 6. So you have 2x6, right? Similarly, you have the x2 now. So x2 itself is 0. So you take x2 as a 1. Make it this equals true. Okay, so you have x2 as a 1, right? And then x3, so this is the now x3, right? So x3 is giving you 1x5. I'm sorry, here x3, x5, and that's it. Now x4, which is this, that gives you x5 and 3x6. So x4 is giving you x5 and 3x6, right? Now x5, which is 0, right? That gives you 1 of x5, and x6, that gives you 0, that is 0, that gives you also 1, which is 1x6, right? This is how you get the vectors of the basis of the null space. Now if you write in the space form or the matrix form, so your basis of null space, there are 3 of them. So you have these, which is x2 column, right? And you have minus 4, 1, and this rest of them is basically zeros. So you have 0, 0, 0, 0. You have all, you just fill all this other stuff as with the zeros. That's it. Ready? So now you have -4, 1, and you have 1, 2, 3, 4 zeros. That is your x2. And you have x5 column, which is you have 3, 0, 1, 1, and 0. 3, 0, 1, 1, another 1, and 0. Okay? And you have the x6, which is giving you 2, 0, 0, 3, 0, and 1. That's all. That's how you find the basis of the null space. Now the dimension of the null space is similar to the dimension of row and column space. So dimension here is also 3 because you have 3 columns of the null space. That's how you find the null space, basis, and dimension. That's how you find the column space, row space, and null space as dimension and basis. Thank you very much for watching this video.